Hey guys, good evening. Hope everyone is doing good. So, today I welcome you all to this continued series on our data engineering series. And I hope this session will be very beneficial to you again. So, today we are covering up the eighth part of our data engineering series. And to be honest, I'm very glad for the amazing response I got from you all. So, before we jump to the video, who are we? We are Data Valley, the fastest growing edtech company of 2025. If you haven't checked on our channel, do check out the different videos that we publish in our YouTube channel, where we stream different subjects like data science, data analytics, data engineering, Python, Java, software development, ethical hacking. So we teach multiple domain. So please do check on our channel, and to engage with our IT solutions or trainings, or if you need any help with your placement and in your career, do check our website at datavalley.ai, where you will find a good rough idea about what we can do and how we can help you as well. So please do find our website and try to have a look, and feel free to ring to one of our colleague. They'll get back to you and they'll help you with your further career development. Myself, Franklin, I have almost 3+ years of experience as a data engineer, and I'm very excited and happy to bring you all these kind of knowledgeable and in demand, market demand questions. So it is beneficial to you, and feel free to share the video with your fellow data engineers or whoever is trying to get into the field of data engineering. It'll be very useful to them. If you like the video, do give a thumbs up, and if you have any questions, drop your questions in the comment section. Let's jump to our video for today. Okay, that's all right. So unlike how we used to start our data engineering series, where we dive deep into different topics, right? Previously, we used to discuss topics like SQL, ETL, Spark, cloud technology, all at one go, right? But rather, from the last data engineering series 7, we have started to focus just in one stream per day. So, in the previous one, we discussed about Spark technology. And today, I want to dive deep into cloud technologies because, as a data engineer, and especially with this era, everything is cloud based. So today we are covering up a bit on cloud, okay, so that it benefits your cloud knowledge as well. Our first question for the day is, what is IaaS, PaaS, and SaaS, and how are they different? You can also call them as IaaS, PaaS, and SaaS. So this is the short way you can name them. Okay, what are those? What are the three terms that I have given there? In the cloud computing world, okay, you have three kind of service model. These three, the IaaS, PaaS, and SaaS, are completely different to each other, and they are different in a way that what kind of control and what kind of management do you get with these services. So that is the major or core difference between IaaS, PaaS, and SaaS. So your level of control and your management of users. So that is your difference in your service model. Okay, what do I mean by service model? Okay, let's put it this way. Let's say you're trying to host an EC2 server, okay? Or let's say you're trying to host some compute resources from your cloud provider. When you try to start some compute in your cloud provider, I have few questions to you. Do you own the hardware? Do you order, purchase, and then install all the necessary cables and then run your hardware? No, it doesn't work that way, right? So if you need a service, or let's say in our simple terms, let's say you want some compute resource, you request to your cloud provider, and then it will be initiated from the cloud provider's end to provide you with the necessary or requested resources, right? But when you request for certain services, they differ in a way. What kind of control do you get? For example, let's say you're using a Gmail, okay? To use your Gmail, do you use any hardware system? Do you purchase any hardware system? Do you establish cables? Do you develop any software to host this Gmail? We don't do anything, right? But what do? We just log in and we start using Gmail. So simple as that. Different kinds of services come with different service model. So in that kind of model, we have three types. Those are IaaS, PaaS, and SaaS. Let's dive a bit more foundational and then we'll dig deeper. Okay, what is IaaS? So IaaS stands for Infrastructure as a Service. As the name suggests, you get infrastructure as a service, or you can just name it as you get the hardware or your compute resources as your service. What do I mean by infrastructure or hardware systems or computing resource? It includes services like servers, storage, networking. For example, you want to run a database. Where does it run? It is hosted in the cloud provider, and the cloud provider hosts all these servers. Let's say you want to save some files into your cloud. So this storage system is held by your cloud provider. Okay. Let's say you want to kind of establish some network or connection. Who is establishing all these connections? So you have your cables, you have your routers, you have your switches. These kind of devices are hosted by your cloud provider, and that is why I mean by infrastructure as a service. So your cloud provider provides you with all the hardware provisioning and your infrastructure. And the next one, we have PaaS, or platform as a service. So talking about PaaS, they offer you a platform where you can develop, run, and manage your applications, abstracting away from infrastructure management. So let's say you have an application, you have developed it, okay? You have finished testing and now you want to put it into production. So what do you need? You need an infrastructure that can host these applications, right? So what do? You request the cloud provider for your just infrastructure, okay? So whatever the resources you need, you just request for it, and all you got to do is put your application, run it. Or let's say it's in development, okay, it's okay. The cloud provider will provide you with the infrastructure and compute resources. On top, you develop your application, right? And then at the last, we have SaaS, or software as a service. So talking about SaaS, the provider provides you with a fully managed software application, okay? So when they provide you with the software or the full software application, as a user or a customer, you don't have to worry about provisioning of the resources. You don't have to worry about the management of your application. You don't have to worry about developing the application. All you gotta do is just use the software. Now let's dive a bit deeper to understand what exactly are these and how are we using it in a daily fashion. So I've got a big pyramid in here, as you see. So I've got infrastructure as a service, platform as a service, and software as a service. As the picture denotes, infrastructure service forms the base of your service model. So you want to have more control, have your infrastructure as a service. And on top of this infrastructure, you build your platform. Okay. So you'll so the main basis infrastructure. So what do I mean? Let's say you are trying to develop an Python application. Okay, let's say you're trying to develop a software. So where do you develop all this? How do you develop all this? So even to write your first line of code, you need an infrastructure that can host that particular application, right? So that's where, for example, in our case, let's say in a general term, okay, without laptop, it is not possible for me to write any code, right? So my Python is an infrastructure that my laptop is the infrastructure or the hardware that I require. So in the infrastructure as a service, you get your computing resource, and on top you build your application, that is your platform as a service. So you get a platform where you can develop and run and host your application. And on top of PaaS and IaaS, you get your software as a service where you just log in and start using the application. No development and no provisioning. All right, let's run into a bit of a detailed breakdown. At first, we have infrastructure as a service. The focus of IaaS is that you are provided with virtualized computing resources. Talking about computing resources, it can be servers, it can be a storage, it can be a networking, whatever. All these kind of computing resources are provided to you via internet. And as a user, what is your responsibility? So the provider will provide you with the infrastructure, and to this infrastructure, it's the responsibility of a customer to manage the OS. It is the responsibility of the customer to host any application. It is the responsibility of the customer to hold the data. And all these are handled by the user, while all the hardware and infrastructure is maintained or taken care by your cloud provider. Okay, the infrastructure is taken care, but anything you build on top of your infrastructure must be taken care by us as a user. An example is we have Amazon Web Service, we have Microsoft Azure, we have Google Compute Engine. So these cloud providers provide us with the infrastructure, right? All you gotta do is, develop something on top of whatever the compute resources that you have requested. And the use case for IaaS is that, let's say you run a business, okay, and you need a complete flexibility and control over your infrastructure. Okay, in that case, you have to go for your IaaS, because let's say uh, there is not necessary compute resources available at a point. Okay, it is going to cost your company or your business profit. So if you request for infrastructure as a service, you are going to take complete control, and you're going to have complete flexibility over the infrastructure. So therefore it will be helpful for you to manage your fluctuating computing needs. And then we have got PaaS. PaaS is platform as a service. And what is the focus of a platform as a service? Platform as a service provides us with a platform where we can develop, run, and manage applications, including tools and environment for developments. Okay, so you have got the infrastructure now, and now you've got a you've got a platform as well. All you got to do is you have to develop, run, host, manage your application. So whatever the tools that is required, whatever the environment that you need, so whatever the dependencies that you need, that you have to provision it by yourself. So what is the responsibility between the user and the cloud provider? In PaaS, the user focuses more on developing and deploying the application, and the cloud provider, they will manage all your underlying infrastructure and the platform. And few examples include Google App Engine, AWS Elastic Beanstalk, and Heroku. The ideal use case for a PaaS would be where you need to streamline an application development. Okay, and once you streamline your application, now you want to deploy it. In that kind of use cases, you can obviously go for PaaS, and it is especially useful for scenarios where you have web and mobile applications. And then we have got SaaS, and SaaS stands for software as a service. So the main focus of a SaaS is to deliver you with these software applications, eliminating the need for infrastructure provisioning, local installation, and maintenance. How do you use your Gmail? All you gotta do is install the app, or you just log into your Gmail via Chrome browser or whatever the internet browsers that you use. You just log in and then you start using your software straight away. So you're not provisioning any infrastructure for your Gmail, or you're not developing an application to host a particular application called Gmail. All you're doing is just log in and using it straight away. So it is a software as a service. And what is the responsibility of a user and what is the responsibility of a cloud provider? As a user, we have to take care of accessing and utilizing the software. For example, your login credentials. As a user, you gotta keep it safe. You gotta protect it. You are making sure that it's held secure rather than being spread out to different people. And as a cloud provider, they'll handle all the aspects of your infrastructure, your platform, your updates, your maintenance, your security patch, your software. All is maintained by your cloud provider. And the best example for SaaS is you've got Gmail, you've got Salesforce, Dropbox. We have got multiple. Even Netflix. Netflix is a very good example of your SaaS. You don't develop anything. You just log in. You start using your Netflix. So Netflix is a software as a service. And the ideal use case is that for any business that needs just ready to use software applications, then software as a service is the go for them. And the ready to use software applications would include few of the softwares like CRM softwares, like email hosting software, collaborating, like let's say Notion, something like that. You need something that you have to collaborate with your people. So these kind of ready to use softwares are a part of software as a service. And here I've got one more pyramid explaining where each of the roles for different people come under the different service model. So I've got the cloud service model, the SaaS, PaaS, and IaaS. So infrastructure as a service is our base. So in this, you can have services like StackScale, AWS, VMware, Azure. So this is where your compute, your storage, and all your servers are hosted. And this is maintained by network architects and IT administrators. And on top of your infrastructure, you have your platform as a service where you develop a particular application. And that is where your software developers come into play. And few of your platform as a service are Flynn, Cloud Foundry, Heroku, OpenShift, Elastic Beanstalk. So you have your platform ready, you come and you develop your application straight away. And then on top of your PaaS foundation, you have your SaaS. So SaaS is software as a service, and that is where only the users come into play. So there is no role for infrastructure provisioning or a development of application, nothing. So user just comes in, they use. And few of your SaaS includes softwares like Gmail, Netflix, Trello, Slack, Akuma by Mail, Office 365. In short, infrastructure as a service provides you with the foundation, that is your infrastructure, and PaaS builds upon that foundation. So whatever application you're hosting or developing, that comes on top of your infrastructure as a service. And SaaS, you just use the finished product or the finished application. So each of these model comes with different level of control and management, as we have seen already. And depending on the business use case and what model they are opting for, and depending on whatever the management or the technical capability they are looking for, it might vary. And depending on that use case, you have to go for your cloud service model. And then the next question is, what is the shared responsibility model in cloud computing? So cloud computing has an important model called shared responsibility. So what do I mean by a shared responsibility model, and why do we need it? So in the cloud computing world, there is two persons, or let's say two important community, that are very responsible to run your compute resources. One set of community is where the resources are provided from. So I'm talking about your cloud provider. And the second set of community is the users who are using these compute resources provided from the cloud provider. So we have user at the one side, or customer, and then we have the provider themselves. So between these two roles, okay, the provider and the consumer, there is a shared responsibility of how you use the particular compute resources. So this is the point about your shared responsibility model, where the responsibilities are shared between the cloud provider and the customer. The shared responsibility model in cloud computing defines how security and operational responsibilities are divided between cloud provider and its customers. So talking about the security and operational responsibilities, these are the core concepts, okay? The security and your optional operational responsibility. So these two important core things separate how the responsibilities are shared between the user and the cloud provider. The shared responsibility model clarifies that while the provider secures the underlying infrastructure, that is the cloud provider, the customer is responsible for securing what they put in it. So it includes the data and application. So what I'm trying to tell is the cloud provider, because they host the data centers and provide us with the compute resources, it is their duty to take care or manage the underlying physical infrastructure. But as a user or a customer, it is your responsibility to manage whatever the application or your data, whatever you have or whatever you have developed. It is your responsibility to protect and secure the data and your application. And even in the shared responsibility model, depending on the service model, okay, which we discussed earlier, the IaaS, PaaS, and SaaS, the responsibility will quite vary, which we will see a little bit later. So this is a please take a screenshot of this, because this is very important. And in interview, they wouldn't just ask you, can you explain the shared responsibility model? They wouldn't be asking you any foundational type of questions. Rather, they will ask you like, okay, there is a problem in the network, and some dodgy IP address is trying to get into the system and breach your security. So how would you handle it, and who is it responsible for? So in that case, yeah, you will have to know that who is responsible for providing us with that level of security, and who does that. And as a user, or as a host, you must know how you are going to secure your cloud. So be I ask you, I request you, please pay attention to this concept, because this is very, very important. The first thing we have on top, customer responsibility shaded in blue, and then we have the cloud provider's responsibility shaded in yellow. I didn't get a better picture, that's why I had to put AWS responsibility. But this is same for most of the cloud providers, okay? So you don't have to worry about, I'm into different clouds, so I mentioned AWS, so should I just leave? No, I've just taken this picture because it had a better representation. But as a cloud provider and as a customer, the responsibilities are same across different service or cloud service providers. In simple, how you can remember this: as a customer, your responsibility is to secure what is in the cloud, okay? And as a cloud provider, it is the duty of the cloud provider to secure their cloud itself. So they secure their cloud, and you secure whatever is in the cloud. Okay, there is a difference, right? So in other terms, instead of cloud, how I can tell this: the cloud provider takes care of the infrastructure, and as a customer, you take care of whatever you put inside the cloud. It can be an application, it can be data, it can be your, depending on different service model. So let's dive deep to understand the responsibility of a customer first. As a customer, it is our duty to secure our customer data. Let's say you are hosting a database. To that particular database, there is some regular transactions happening. So while transactions happen, your data gets stored, right? Let's say there is some random or a dodgy IP that is trying to access your database, and they want to take all the information from your database. So whose responsibility is it to protect your database against this particular dodgy IP? So as a customer or a user, it is your responsibility, because you have hosted a database. The database is provided by your cloud provider. Fine. but you gotta protect the data that is in your database. So you gotta ensure that you provide proper credentials. Only with the proper credentials someone can access your database. Then let's say you have some dodgy IP, you gotta block it, you gotta install some firewall. And these kind of steps must be handled by a user in the customer responsibility. And then the platform that we run, the applications, the identity and access management comes under the customer's responsibility. So the application development is obviously from a software developer. Then you got identity and access management. If someone doesn't have a credential, they mustn't be able to access your database or your data, right? So this kind of setup is done by the customer. The operating system, the network, the firewall configuration, these are all managed by the user. So for example, let's say I want a Windows operating system. Yes, it is my responsibility to have that. I got to choose what operating system do I need. Talking about network, okay, you need a separate VPC, go for it. You need a separate security groups, and you got to ensure that you blacklist and whitelist IPs. You got to use firewall to protect against unusual IP attacks. Then it is you who have to install and configure all your network and firewall configurations. As a user, it is our responsibility to manage the client side data encryption. So whatever the data that we have, okay, the client side, it is the responsibility of a user to encrypt it. Okay, as a user, it is your responsibility to ensure that your data is in integrity. It is the responsibility of a user to authenticate. Okay, so these kind of responsibilities comes under the customer. So to have your server side encryption, okay, that is the responsibility of a customer again. Let's say you want to configure and you want to protect your networking. Yes, it is the responsibility of a customer. So you got to protect your networking traffic protection, and you can have different kind of setups, okay, like firewall. You can have your data encrypted, you can have your proper identity and access management, which means that proper credentials. So these kind of setups, okay, security in the cloud is handled by the customer. Talking about security of the cloud, okay, as a software, okay, let's say you have compute resources, let's say you have a storage, let's say you have some database, and let's say you have some networking devices. As a user, you don't purchase or you don't run all these kind of compute resources at your home or in your office, right? So all you do is just request and you use it. So from the cloud provider side, it is their responsibility to physically take care of your compute resources, your storage, your database, and your networking. Talking about the hardware and global infrastructure, so regions, for example, talking about regions, you have varieties of regions in your cloud provider, right? And you as a user can opt for the best one based on your geolocation. So talking about regions, let's say I want to, I'm in India and I want to host some software within the India. So India is a region, UK is a region, Switzerland is a region. So then you have availability zones. What do I mean by availability zone? So inside the region, the data centers are split across different zones. So what do I mean by zones? So let's say India is the region. Okay, I'm having a cloud and I'm hosting resources from the Indian region. And within the Indian region, I can have my data centers in multiple locations. Let's say in India you have few of your data centers in Mumbai, and then let's say few of your data centers are hosted in another state like Karnataka, and there is another set of data center being hosted in Chennai. Okay, so what it means that you have three availability zones within the region. Okay, so region, and within a region you have got availability zone, and within the availability zone you have got edge locations. So all these physical management or the physical protection, physical security must be maintained by your cloud provider. So that is the responsibility of your cloud provider. And let's have more detailed breakdown as well. And let's see how it differs based on the different service model. As a cloud provider, it is the responsibility of them to secure your cloud. Okay, or in other words, ensuring the security of the cloud is by your cloud provider. This includes managing your physical infrastructure like data centers, hardware, and virtualization layer. And they must maintain the underlying platform as well. And what do I mean by underlying platform? So it is the responsibility of a cloud provider to take care of the operating system, the network, the storage, and they got to ensure that these resources are available and they are reliable at all point of time. And as a customer, you got to ensure that you provide security in the cloud. So what do I mean? So whatever the data that is inside the resource, whoever gets to access it, the application that you have hosted, whatever the access control that you have set, these kind of configurations must be set by the user themselves. Talking about the securing the workloads, let's say you are running an application and now you are trying to upgrade it and you have got few patches to fix. These kind of patchworks must be taken care by the customer. And let's say you are updating your OS, it is the responsibility of a user. And to manage the user identities and protecting the data, it is the responsibility of a customer. So these are the difference in short for your both cloud provider and your customer's responsibility. And depending on the service model, there is a huge difference as well. So with in infrastructure, you know that your infrastructure is provided by your cloud service provider, and as a customer we manage the OS, the application, the data that is put on top of the infrastructure. In the past, what do you do? So we must secure our platform. Sorry, the cloud provider will secure the platform, and as a user all we got to do is develop and deploy our application. And then we have got SaaS, where the provider themselves will provide you the application, the underlying infrastructure, and we as a user just have to manage, what data we put in and who gets to access it. So I've got a good picture in here. If you can, please take a screenshot. So as you can see here, the green is what we manage, and the blue shaded ones are the managed by your cloud provider. So I have added one more thing here as on-premises private cloud. So there are companies that doesn't need to compromise on their security at any level, not at infrastructure level, not at software level, not at in service edge location. They don't want to compromise on any of the provisions or any of the software they run for their company. In that case, you can host your data centers or your cloud within the on-premise. And what is the flexibility you have with your on-premise private data center is that you get to have access for your data, you get access for your application, runtime, operating system, virtual machine, the underlying infrastructure, compute, network, and storage. Everything can be managed by the user or a customer. Talking about infrastructure as a service, you are getting infrastructure from your cloud provider, which are your storage, your networking devices, your compute. So all these are taken care by your cloud provider, and anything on top of your infrastructure, which includes virtual machine, OS, runtime, application, data and access, all these must be maintained by an user. And in the platform as a service, on top of your infrastructure as a service, you are provided with the virtual machine, an operating system, and a runtime. So all you gotta do is just develop your application, and you gotta maintain who gets to access what. So this is the responsibility in a PaaS model. And then we have got a SaaS model. In SaaS model, even the application is hosted by your cloud provider. Therefore, you no need to develop or deploy and secure any or configure any kind of application related functionalities. As a user, you gotta just keep an eye on data and who gets to access what. So depending on the service model, as you can see, The shared responsibility differs on who and what we take care of, or who and what the cloud provider takes care of. What is the benefit of this shared responsibility? The main importance is that you get a clear accountability. What do I mean by accountability? Accountability is like taking responsibility for something, or something that you do. Okay, so by your shared responsibility model, you are getting a clear accountability that who gets to manage what. So this model ensures that both the provider and customer understand their roles and responsibility, preventing confusion and potential security gaps. And then the next importance is that the shared responsibility model provides us with effective security. So how does it do that? By dividing the responsibilities, the model allows for a more secure approach to security, with each party addressing their respective areas of control. So first we saw that there is a clear partition between who takes care of what based on the role and responsibility. And by dividing the responsibilities, now we have a focused approach to take care and address what the respective role takes care in the. And then we have got the resource optimization. So in this we are helped with allocating resources effectively, as the provider handles the infrastructure security while the customer manages the specific workload. So these are the clear cut importance of having a shared responsibility model. And the third question for the day is, how do managed data pipeline service, example AWS Glue, ADF, GCP data flow, reduce operational complexity? What do I mean by data pipeline service or managed data pipeline service? Let's split it. Okay, so data pipeline service. So talking about data pipeline service, you are provided with a tool which can handle or develop and work out your data pipeline. Why do you use data pipeline? You use data pipeline to connect between the source and your target, and you perform an ETL job to make sure that the data flows between the source and the target. So what do I mean by a managed data pipeline service then? How is it different to your data pipeline service? In pipeline service, you develop the pipeline. Okay, you are provided with the platform and you develop a pipeline. But in managed data pipeline service, the cloud provider themselves will take care of all the underlying infrastructure and the platform. So what do I mean? Let's say I'm using an elastic map reduce, okay, AWS EMR, which is hosted in your Amazon cloud. If I use AWS EMR, what I gotta do? I gotta configure the hardware size. I gotta configure my cluster size. I gotta configure what memory and what disk and what is the storage and processing speed I require. I am going to specify what are the resources and their specification, and then I'll be running a pipeline. Okay, then I'll be developing a Python code or ETL script, and then I'll be running my pipeline. But talking about your managed data pipeline service, you don't have to worry about infrastructure because that is managed by your cloud service provider. As a user, all you got to do is develop a logic, put it inside the managed data pipeline service, and your job is done. So the leading providers, okay, the Amazon, GCP, and Azure, they provide us with corresponding managed data pipeline service called as AWS Glue, Azure Data Factory by Microsoft, and Google Cloud Data Flow from your GCP platform. Okay, so how do they reduce the operational complexity? Managed pipeline service reduce operational complexity by abstracting away infrastructure management and providing built-in features for various aspects of data pipeline operations. So in the managed data pipeline service, anything to do with your operational complexity. So what do I mean by operational complexity? So anything in relation to configuring your infrastructure, or setting your cluster size, or working out on your scaling issues. All these are handled by your cloud provider themselves, and you don't have to worry about it. And what are the key ways in which our complexity is reduced? First thing, they provide us with the serverless and managed infrastructure. So, what do I mean by serverless? Does it mean that you don't use a server? No. Talking about serverless, yes, you will be using a server. Okay. But the key difference is that you wouldn't be provisioning a server. So, there is a difference. So, let's say you're hosting an EMR in your AWS cloud. What do? You configure each and every configuration for your server, right? So what size do you want? What cluster size are you expecting? So these kind of different setups are managed by you. But in serverless, all you gotta do is, okay, I need a server. Simple. So you run your application, the server is taken care by your cloud provider. So serverless doesn't mean that you don't have a server. Okay. You use a server, but you don't configure the server. Okay. That is the difference between sorry. Okay. That is the difference between the server and serverless configuration. So these services eliminate the need to provision, manage, and scale servers or clusters. The cloud provider handles the underlying infrastructure, including patching, updates, and scaling based on workload demands, freeing up operational teams from these responsibilities. So, as I said earlier, you're not worrying about your infrastructure management. Any scaling issues, do not worry about it. The cloud provider will take care of it. You don't have to worry about patching, updating, or securing your platform. Nothing. All you got to do is you have your infrastructure ready, put in your pipeline code or your script, and your job is done. It provides us with the automated scaling. So first your infrastructure is provided, and then now you have automated scaling. In the normal setup, let's say you are having a lot of transactions or a huge volume of data needs to be worked out. So what do? You resize your cluster configuration, right? This is the normal way how you can handle your large data transactions happening. But with the managed pipeline service, you don't have to worry about the scaling issues, as the cloud provider themselves will make sure that whatever the necessary resources are needed, they are just added up to your pipeline as a service. So automatic scaling up and automatic scaling down by your cloud provider. And then we have got built-in orchestration and scheduling. Using these kind of tools like ADF, Glue, and GCP data flow, don't have to worry about having a special or an external tool where you can orchestrate and schedule your job, because these providers themselves have features to define and schedule your jobs. So even to manage your dependency between the different pipeline stages, you have a capacity or ability. You just need to provide the dependencies, and you just have to create your workflow, and then you can just schedule it, and it could provide us with the same functionality that happens with the external third party vendor tools. And then talking about monitoring and logging, these managed pipeline services provide us with the dashboard, which helps us to understand the pipeline performance, if the job has been successful, the status, if there was any particular error because of which the job is failing, what kind of resources have been used, what is the time it has taken to complete a job. So whatever the issues that you can have, okay, with a pipeline, because they are managed service, you get to have a clear monitoring, and you get to have a clear idea about how to troubleshoot these kind of errors happening in your pipeline as a service. And then you have got error handling and retries. Many services include built-in mechanisms for handling errors and automatically retrying failed tasks, improving pipeline resilience and reducing the need for manual intervention in case of transient issues. So what do I mean by error handling and retries? Let's say I'm running an AWS Glue, okay, which is a ETL tool provided from the Amazon cloud. I have a feature, okay. All I gotta say is, okay, for these kind of minutes, give a gap and then retry a particular glue job, okay. If I could specify it in case if there was any transient errors. So what do I mean by transient errors or transient issues? These errors can happen due to multiple reasons. Let's say the job and your script is all good, but there was a sudden network issue, okay. So you don't have to wait for anyone, or you don't have to wait for any manual intervention, because your pipeline as a service is capable to retry all the mechanisms in a set period of an interval. So it helps us in a lot of way because it is automating our workflow. And then it provides us with data cataloging and metadata management. What do I mean by data cataloging and metadata management? So we have a service called, for example, in Amazon Cloud, we have a service called AWS Glue Data Catalog. So uh, what this Glue Data Catalog will do is, it'll help to manage the metadata. Okay, therefore, helping us to discover and understand and track data sets across different sources and services. So let me try to explain it in a very simple fashion. Okay, let's say you have a pipeline and your goal is to take the data from a source and drop it into the target. And let's say whatever the data that you are processing, you are getting only three column data. Okay, this is just an example. In real world use case, you might get large or a huge volume of data with multiple columns and rows. But let's say you have some data which has only three columns, and by some chance tomorrow you're having a different file system that is loaded into your S3 or your storage, and now your glue job is waiting to process it, and now it has four columns. So there is a conflict, right? Yesterday you had three columns and today you're having four columns. So there is a conflict, and there are high chances that your pipeline might break. So what this glue data catalog will do is, this glue data catalog will keep a track of your metadata. So what column you had, what is the data type of the column, and there is also a feature where you can select what do you want to do with this difference or conflict of data. So you have different options like ignore the new column, or you can add it to your column, or add it and wait for the manual validation. So you have different kinds of setup within the managed pipeline service, so which is very beneficial because your pipeline is going to run very smooth. Then it provides us with a simplified data integration. So let's say you have a different source and your different target. Let's say I have all my data in my S3, okay, which is a storage service in AWS, and I want to push all this data from my data lake or S3 to a Snowflake data warehouse. So what this does is, the managed pipeline services provide us with different capabilities that can help us to connect between these different sources. Okay, so in some cases all you got to do is just load an JDBC or a ODBC connector, and then you can connect and work with your target or your source database or a data warehouse. The final question for the day is, how do you secure sensitive data stored in the cloud? Is it necessary to secure a data in first place? Yes. As a cloud, or as an application developer, or as a data engineer, whatever the data that is being consumed by your company or your business, it is the responsibility of every individual within the company. Okay, I mean, you are the one who is going to work on it, or you are the one who is going to secure it. But in general note, as a company, it is a responsibility to secure any kind of data in first place. And let's say the data is very sensitive. What do I mean by sensitive data? Sensitive data could be your biometric data, your date of birth, your phone number, your address, your account details. So these all come under this sensitive data. So as a data engineer or a cloud engineer, it is your duty to secure all the sensitive data within the cloud. Let's see how we can install different kind of strategies to secure our cloud data. To secure the sensitive data, we have to implement a multi-layered approach. What do I mean by a multi-layered approach? We will see about this at the end stage, because once I explain all the strategies that we have in place, you will have a clear picture of how to, you know, configure this in our original setup. So the securing the cloud, or securing the sensitive data in the cloud, involves implementing strong access controls, encrypting data at rest and in transit, regularly monitoring and auditing cloud activity, and educating users on data security best practices. Okay, uh, for every term in here, do not worry, I'm going to explain it because I've broken it down here. You'll get a clear idea now. So the first important step is provide a strong access control. So, what should I do to provide a strong access control? First things first, always have a MFA, which stands for multi factor authentication. So, what this is going to do is, let's say you're trying to access to your Gmail, okay? If you have enabled MFA, when you try to log into your Gmail, you're going to get a notification asking you, is that is you? If that is you, put this passcode within the login page. So, by which not just your password and your credential, but also your multi factor authentication acts as your second layer of verification, ensuring that a proper access control is provided. And then we have got role based access control. What do I mean by role based access control? So, as the term suggests, depending on the role, you provide a different level of access control. So, that is what RBAC means, or role based access control. So, within a company, there are multiple roles, right? Let's say someone is working in the receptionist, as a receptionist, and let's say myself, Franklin, working as a data engineer. So I'm getting few transactions happening for my company. Should the receptionist get access to the database? No, she never needs to have access to the database, because as a data engineer, or in the next further, processing, the business intelligence team or data analyst team could access my the data. But it is not the role, or it's not responsibility for a receptionist to access those databases. So we gotta provide role based access. Only if someone has a particular role, for example, a data engineer, a data analyst, only for that role allow access to access the data or a database. So we gotta provide a shared responsibility and role depending on the access levels that we would like to have. And then we have least privilege principle or policy. So what does this least privilege policy mean? It is the policy of providing a user with minimum level of access that is just necessary to perform a job. For example, I am a data engineer, and then let's say you have your company's cloud engineer, okay? The cloud engineer might have multiple applications, or multiple databases, multiple warehouses, multiple web applications running within the uh, cloud, right? And it is all hosted by your cloud engineer, or let's say your data architect. And now, as a data engineer, it is not my role to have a look on all these applications. It is not the responsibility of a data engineer to go and have a look on how the web applications are running in the backend, because it is not my responsibility. Simple as that. So yeah, I'm getting a role based access, and on top I'm getting only the least privilege. And let's say I want to query a data from a data warehouse. So I must not have full access. So if I have full access, let's say I just deleted something by accident, would it be able to would it be possible for me to recover? Yes, I can recover, but yet I'm risking all the data, I'm risking all the platform, I'm risking the security of my system. Therefore, depending on the role and depending on the responsibility, we have to provide an user with the least privilege policy, providing the minimal or the lowest level of access. And then we have got data encryption. So, talking about data at rest and data in transcription, in transit. So, what do I mean by data at rest? The data is just going to be in your storage. That is the data at rest. And what do I mean by data in transit? So, the data from your particular, let's say, your storage, now we are transiting into a data warehouse. Okay, we are establishing a pipeline, and because you have established a pipeline, the data is flowing from your database to a data warehouse. So your data is transferring or moving, right? So this is what I mean by data in transit. So we gotta provide with the encryption capacity. So even the data can be at rest or the data can be in transit, but we gotta encrypt. So what happens with the encryption at rest? You protect data stored on cloud service by converting it into an unreadable format, making it inaccessible without a decryption key. So if someone needs to access your data from your database and they would like to read it, they need this decryption key to read the encrypted data. Okay, let's say your WhatsApp communications are end to end encrypted, right? So if a third party or if a scammer is trying to read all your data, they wouldn't be able to read your data because your data is encrypted, and even if they get to access it, they will not understand it because it is in an unreadable format. Then encryption in transit, you gotta secure data as it travels between your devices and the cloud, preventing interception and unauthorized access. So while your data is moving, ensure that your data is encrypted and it is not available for anyone to read it or have an unauthorized access. Then you have got monitoring and auditing. So whatever the data that you have, whatever the systems that you have in place to perform a particular data job, you gotta track it regularly, and you gotta look for the patterns and must look for anomalies, and you gotta check if there is any kind of potential security threats for your data. It's the role of a data engineer to monitor and audit if there is any data that is at risk. You got to perform regular audits. So performing periodic review of your security configurations, access control, and other security measures to identify and address vulnerabilities. So monitor regularly and ensure that you perform audit. So for example, you have audit trail in your Amazon cloud. So you gotta audit all your trailing activities. You gotta identify a pattern, and then you are going to come out to a conclusion that if there are any vulnerabilities happening within your system, you gotta set intrusion detection systems. So to use ideas, you use tools to monitor the network traffic for suspicious activity and potential threats. So using ideas, you can track down DDoS attacks if a particular IP is trying to get into your system. So for different types of network traffics, you can try to come up with a pattern to understand if there is any suspicious activity happening, and then you can come to a conclusion, yes, there is a potential threat, and if there is a potential threat, I'm going to follow a particular policy to protect or safeguard my system. And there are other considerations as well. So you have got data loss prevention tools. So you can implement solutions to prevent sensitive data from leaving the cloud environment through unauthorized channels. So if you set DLP tools, if someone is trying to access and then take all your data from your system, this data loss prevention tools will prevent the data from leaving your particular source. You can establish backup and recovery. So if your mobile is lost, what would you do? How would you recover the photos? So you would have every photos or your documents, you put them all into a backup, right? Or a drive. Similarly, talking in a business use case, you got to establish a backup and a recovery plan to protect against the data loss. Okay, data loss could be in a multiple format. Okay, it's not just about losing data by someone accessing and deleting it. No, there are different reasons. For example, you might delete it by accident, so how are you going to recover? So you need to set up a backup plan. Let's say you have an hardware failure, then how are you going to recover all your data? Let's say you have a security breach. Okay, it's fine, so now how are you going to recover it? Let's say one of your hosted hardware devices, okay, in your data center there has been a natural calamity. I hope it doesn't happen, but let's say there is a breach, and let's say there is too much rain and your data center has lost all the electricity. How do you then establish a security? Make sure that all your data is backed up somewhere and you're able to recover it. You can classify data. Okay, so whatever the data that you're getting, you can set the level of criticality based on how sensitive the data is. And by setting these security measures, you can ensure that your data is safe. And then you have got employee training. So you can educate employees about cloud security best practices. So in your company, let's say you are a senior or you can be lead, so make sure that your employees are competent enough to handle the sensitive data. So you can conduct regular seminars, you can conduct regular meetings, you can conduct regular discussions about how to handle the data, what are the procedures we have to we have in place to back up and recover, what are the policies and rules we must follow as a engineers to protect the data. For example, it could even include logging out your system as soon as you move away from your system. So that is a good practice, isn't it? So make sure that you have employee training in place, which also suggests about setting a strong password and MFAs in place. Then you got cloud security posture management, other words is DSPM. So you can utilize tools that continuously access and improve your cloud security posture. So you're going to continuously access and check if there is any room for security posture management. And then you have secure API usage. So as a data engineer, you will be using APIs, right? You'll be Why do you use APIs? You use APIs to fetch data from some source, right? Or in other words, or another fashion, you could be using APIs to drop your data into a particular target. It doesn't matter, but when you use APIs, make sure that they are properly secured. Okay, if someone is getting access to these APIs, then there is a data breach possibility. So ensure that your API is very secure and it is able to prevent unauthorized access. Then try to keep up with the compliance. Okay, for different geolocation and different companies, the compliance rules might differ, but make sure that you follow it. For example, the most common compliance is GDPR. I hope you all would have heard about it. So GDPR is a data protection policy in the UK or EU region. So in the GDPR, they ask you how long would you hold the data, who gets to access it, what is the retention period of the data, when will the data be deleted away from the system. So these kind of policies or compliances are set by either based on geolocation, and on top, for different companies they set their own compliance policies as well. So ensure that your cloud data is secure by practicing all these compliance policies depending on your geo regulations or your industry standards. By implementing these measures, you can significantly reduce the risk of sensitive data being compromised in the cloud and maintain a strong security posture. So, in the start, I mentioned about a multi layered approach, right? So, this is very crucial. So, if you see, I've got different steps for your data security. So, you can implement all these strategies, even, right, if possible. So, if it is possible, try to implement as much as strategies and policies to secure all your data. All right. So that is all for today. I believe we all had a good session about cloud, how do we secure it, how are different services like how it is providing us with a better operational complexity, and what are the service models we have got, and what is the different kind of IaaS, PaaS, and SaaS, how do they differ. So it was a quite a good session. Soon I'll be uploading all these documents to my GitHub. I know I've been telling it long, so I've come up with a strategy. Okay, so my plan is I'll be posting like for every 5-part series. I'm planning to load all these documents to my GitHub or to my LinkedIn. Okay, so you can try to check out or drop a message in my LinkedIn and I'll be able to provide you access. But do not worry about it for now. Mostly in the ninth or the 10th series, I will provide you with a link, because I'm not sure what strategy should I come in. If you have any suggestions, do drop it in the comment section to let me know how I can provide you with these documents, so that it is better for all the user to access it. So that is all for now. I hope you all had a good session. So before we finish, we are Data Valley, the fastest growing edtech company of 2025, and we have got our centers in different countries as well. So we have our headquarters in US, UK, and we have got 4 data centers in Hyderabad as well. So please do, if you're nearby around, do check out on our website, or you can even go to the company and have a visit. And you can ring on these numbers if you're any local to these locations, and our colleagues will be able to guide you and help you with your placement or training. Or let's say you have your company and you need a manpower. Yes, we do provide you with IT people, knowledgeable people who can contribute to your company's growth. So this is all for today. This is Franklin signing off. Thank you so much. Hope to see you in another video. Thank you so much. Bye bye.